In 2009, 96% of all the data that we had for representing complex genetic diseases, that is, the diseases that people die of, such as Alzheimer's, diabetes, cardiovascular disease, metabolic diseases. So 96% of all the data that we had for those diseases that then are used for building models were based on European in 2009. In 2016, it got a little bit better, and we got 81% of all the data only as European ancestry. And you would have expected that as time passes by, that we would have been addressing this discrepancy in terms of the representation of data from different regions from around the world. But actually, that's not what's happened. And if we are comparing the amount of data that we have for building models that predict risk of complex diseases using genomic data, you see that the increase of European samples has exponentially increased. And you can see then how that compares to the actual share of the global population. So we have more than 90 or around 90% of all the data that is European, whereas less than 20% of all the data of all populations in the world are European. So we have clearly a very skewed and biased representation of the data that then helps us diagnose rare and complex genetic disorders. So there's something called pharmacogenomics. So pharmacogenomics is the science that helps us predict, based on the genetic data, your likelihood for metabolizing a drug. So we know that depending on your genetic composition, some drugs are going to work better for you than other drugs.